Hello class, we're back again at 3.3 trig functions and radians. I had made a part 1 video where we walked through a whole bunch of initial kind of refreshing our memory about how to deal with trig functions, but now in radian measure. I'm just going to continue where we left off, which was we just finished solving what does the exact value of cos pi over 2 is. So now we're going to go on to coordinates. So how do we deal with coordinates in radian measure? Basically what we're trying to do is, if on a Cartesian plane we have our terminal arm in one location, we want to find out where is this terminal arm at, and so therefore what is its coordinates. So if it's rotated around and stops at one part, where's the end of that terminal arm? It's a very popular question that comes a lot in trig functions. And so when we think about the x and y coordinate of any part along that's been rotated along the unit circle, basically what ends up happening is that we can always draw a triangle, an acute triangle with the x-axis. And so that helps us because we're trying to find the x value that goes along and then the y value that goes down. And so when we deal with these trig functions, we're talking about this triangle, and so we can think back to cos and sine, because if you remember, cos is dealing with, of any angle, is dealing with the x over r, and sine of theta is always dealing with y over r. And in this case, when we deal with a unit circle, the r value is always 1. And so we can almost reduce it down to a unit circle and say that the x value of a point along the terminal arm would therefore be talking about the cos of that angle. And similarly, the y value is coming from the sine of that angle. And so we are technically talking about that. And so for this question here, when we're trying to find the coordinate of the point that has the measurement of 11 pi over 6, that's what we've drawn here, 11 pi over 6, we're almost quite at, how do I know that? Well, because 12 pi over 6 would be 2 pi. And so we're almost at a full rotation, we're just kind of short of that. And so then that means that we're going to look into the cos of 11 pi over 6. And we'll look at the sine of 11 pi over 6. And so we can do that because we know that the relative acute angle inside here would be pi over 6. And so we go back to our special triangle of 11 pi over 6, which looks like this. And this is pi over 3 over here. So this is root 3, 1, and 2. So if we're trying to find the cos of that, we're going to say that the cos would be root 3 over 2. And the sine of that will be 1 over 2. But we have to always remember our cast rule. And we are in the C quadrant, so this is going to be positive, but this is going to be negative. And so therefore, our coordinate is at root 3 over 2 along the x-axis, and then down the y at negative 1/2. Okay, this is an important formula to know in case we need to ever talk about coordinate. Last but not least, let's try and do the challenge, which is determine the exact value of sine squared 7 pi over 4 plus cos squared 7 pi over 4. And then we have to answer the next question, which does this make sense based on our knowledge of trigonometry? Well, let's write out the question. We want to look at sine squared 7 pi over 4. Then we want to add it to cos squared of 7 pi over 4. A reminder that this squared means that we're basically taking and finding the sine of 7 pi over 4, and then we're going to square that answer. Same with this one. We're going to find the cos of 7 pi over 4, and then we're going to square the answer. So basically it looks like this. We're going to take the sine of 7 pi over 4, and whatever we get, we're going to square it, and then do the cos of 7 pi over 4, and then we're going to square it. So where is 7 pi over 4? So it's always good, as always, to draw a diagram. Well, 7 pi over 4 is almost quite at 8 pi over 4, so it is in the fourth quadrant. So theta equals 7 pi over 4. And that means that our little triangle here will have a relative acute angle of pi over 4, which means that's 1 root 2 would be the side lengths. And so when we're talking about sine, we will say sine 7 pi over 4 would just equal 1 over root 2, or root 2 over 2. And then square that. And then the same with cos, it would be root 2 over 2. But we cannot just leave these answers. We always have to check the cast rule. And so in the cast rule, our cos is positive, but our sine is going to be negative. Is that going to matter? Well, we're going to square it. So not really in this case, but we always want to make sure. Well, when we square this, again, remember that square root and square root are the opposite operation, so they're going to cancel each other out. So it ends up being just 2 over 4. So we're applying the squared, here, basically, and here. So both the denominator and the numerator are going to be squared. This cancels out this, but 2 has to be squared, so that becomes 4. And we're going to do the same over here. That ends up being the same answer of 2 over 4. So 2 over 4 plus 2 over 4 just equals 4 over 4, which now equals 1. And so our answer for sine squared 7 pi over 4 plus cos squared 7 pi over 4 equals just 1. Now the question asks, does this make sense somehow based on our knowledge of trigonometry? Well, let's look at the question again. Basically, if we break it down, the question was just sine squared of some angle plus cos squared of what the same angle ended up equaling 1. Now, this is a trig identity that we have learned last year. So we're going to be seeing this again in Unit 4. So keep that in mind that we might see these types of problems again next unit. But we just proved that this works for a radian measure angle. All right, good luck, have fun.